Kia ora, Year 9. This video is going to look at how we solve equations and what it means to solve an equation. So it's going to start from some pretty easy equation solving where we really don't feel like we need to use algebra to some harder ones where hopefully you'll see how algebra can let us get to more complicated problems. So the first thing I need to tell you about this is that you need to get your maths book out because you're going to be doing some work as you watch this video. Okay, so don't just sit here and let it just flow over you. You need your pen and your maths book, and you need to head it up solving equations, and you can call it video 1. So let's talk about what it means, first of all, to say I'm solving an equation. Well, what we're going to start with is this really, really simple little one. I can hear you all groaning. But let's see, what does it mean to solve this equation here? X plus 4 equals 7. So x is what we call a variable, and we're looking for the value of that thing, that variable, that's going to make this into a true statement. In other words, something plus 4 is equal to 7. Now, we don't need a whole lot of algebra to figure out that the something has got to be equal to 3. Right? So we write down x equals 3, and we call that a solution to the equation x plus 4 equals 7. When we're doing really simple equations like this, we often don't think hard about the mathematical processes that we're using, right? But the first thing that I want you to get down into your notes is this box here, right? So that you record what we mean to solve an equation. So pause the video and just copy that into your books. Then we're going to go on and look at how we are solving things in our head without thinking about them. So when we figured out that the solution to this equation here was x equals 3, we're using the big idea in maths of inverse operations, but we don't need to think about it every time that we use that idea. So let's look at this equation and see how it started out its life. Well, we started with a number, x, and then we took that number and we added 4 to it. So algebraically, we can say we get x plus 4. And that equals 7. So now if we want to solve the equation, we're going to work backwards. And in this case, the working backwards says, well, what's the opposite of adding 4? It's taking away 4. So I started with 7, and I'm going to take 4 away from it. So if we wanted to do algebra working for this equation, I can hear you groaning. Okay. This is what we do. We start with x plus 4 is equal to 7. And remember, we have to keep the equation in balance. So we're going to do the inverse operation to addition. And we're going to make sure we do the same thing to both sides to keep everything in balance. So we're going to take 4 away from the left-hand side, and we're going to take 4 away from the right-hand side. Now look what happens here. I've got plus 4 take away 4, which is nothing. So on the left-hand side, I'm left with just x is equal to 3. And this is a pattern that we're going to follow in many, many situations over the next few years. It just seems a bit silly for an equation as easy as this one, right? But this bubble diagram here for working backwards can come in useful. So what are we going to do now? Well, very quickly, I want us to just practice for these 10 equations, thinking about what each equation means in words. All right, so we're going to write each equation in words. You don't have to write that out in your book. Okay, I'm quite happy for you to pause the video and work with the person next to you and just go through and say, what does this mean? Okay, so it means that I've got a number, and when I subtract 7 from it, the answer is 6. For this one, I've got a number, x. When I multiply it by 4, the answer is 20, and so on. Then what I do want you to record in your books is I want you to write each of those down, and then write down 2 things. Write down the solution, so x equals something, and also state the inverse operation in each case. Okay, so you've got 10 questions. Verbally, I want you to say, what does the equation say in words? And then in your book, I want you to write down the solution. Okay, so each one, the solution, and then what's the inverse operation? Okay, so here are the answers. So pause the video, go back and do them before you look. Now I've written out how we can say the equation in words for each one. And then I've written the solution. and then I've stated the inverse operation. Okay, so this first one was x take away 7 equals 6. This one was 4x equals 20. This one is x plus 5 is equal to 17. This one is x times 5, so 5x is equal to 30. Moving on, we get x divided by 6 equals 3 for this equation. 7 times x, 7x equals 70 was question 6. X divided by 5 equals 20. 5 times x, 5x equals 20. X plus 5 equals 20. And x take away 5 equals 20. So what you should be able to do by the end of this part of the video is go between the following things: the equation, what it means in words, what the solution is, and what the inverse operation is for these one-step equations. Right? And if you need more practice at problems like that, on Google Classroom, there's a sheet to give you another 10 or so to practice on. Right, so now I want to look at how to solve some harder problems, which we call two-step equations. And this is where we do start to use some algebra. So if we think about this equation here, 3x take away 2 is equal to 22. We're going to draw a bubble diagram for this one as well. We started with the number x, then we times it by 3. That gave me 3x. And we took 2 away from the result of that, giving me 3x take away 2, and out popped my answer, which was 22. So let's look at how we can work back now to find x. First, I'm going to do it using a bubble diagram, and then I'm going to show you how to do it algebraically. So looking here, the last thing that I did was I subtracted 2. So when I work backwards, the first thing that I'm going to do is the opposite of that. I'm going to add 2. Before that, I had multiplied by 3. So when I'm working backwards, I'm going to do the inverse operation. I'm going to divide by 3. So we started with 22, right? So 22 was kind of the answer to my expression or equation. And I added 2, so that gets me to 24. And then I divide by 3, and that gets me to 24 divided by 3, which is 8. But we don't want to have to draw bubble diagrams like that. We'd like to be able to do that algebraically. So here's how we keep everything balanced algebraically with a two-step equation. So we start with 3x take away 2 is equal to 22. Now I'm going to write out each little step here, and then we can talk about which ones we don't have to include. What's the opposite of the subtracting 2? Well, it's adding 2. So I'm going to start by adding 2 to both sides. Right? As long as I do the same thing to both sides of the equation, I keep it balanced. Right? Think about what I did in class with the ruler balancing the two pencil cases. So on the left-hand side, I've now got 3x is equal to 24. How do I undo this? Well, I've got 3 times a number. The opposite of multiplication is division. So we want to divide both sides by 3. Remember, with algebra, we use the fractions division sign, not this one. So 3 divided by 3 is 1. We've got one lot of x, which is just x. 24 divided by 3 is 8. So we're done. We've found the solution to this equation. But I know some of you are groaning about how much work we had to show to put that in. So on the next slide, I'm going to talk a little bit about when we're starting out, how we often show full working like that. And as we speed up, we can drop a little bit of that working. Okay, so we're going to look at these examples. We've got 4x plus 5 equals 49. And then the next one we're going to look at is 7x take away 2 is equal to 40. So pause the video and try and work through those two examples in your book, and then I'm going to go through them. Okay, so the last thing that happened here is I've got a 5 added. The opposite of addition, or the inverse, is subtraction. So we're going to start by subtracting 5 from both sides. So that gives me 4x is equal to 44. Now, 4 times a number is 44. I'm going to divide both sides by 4, and I'm going to write down x is equal to 11. Okay, so that's the solution to that equation. Turning to the 7x minus 2 equals 40, I'm going to add 2 to both sides. 7x, take away 2 plus 2 is equal to 40 plus 2. That gives me 7x is equal to 42. 7 times the number is 42. The opposite of times is divides. So we're going to divide both sides by 7, and we get x is equal to 42 divided by 7, which is 6. So notice that I didn't write all of the division line out there. I was quite happy to go from here to here. Just have to be really clear in your head what I'm doing to both sides of the equation. So let's stop there for this video. I'm going to do a second video that's got some harder examples of two-step equations that most of you should be able to get through today. But just before I stop and go to the harder video, I want to go through what I'd like you to have recorded in your maths books. So I'm going to skim back through these slides, and I'm going to put a yellow highlighter box around what I want you to have recorded. So going all the way back to the start, the heading for the lesson is solving equations. Okay, so that needs to be in a box. And then this, being the solution, also needs to be in a box. Right, you don't need to have anything written down from this page. But here, I'd like you to make sure that you've recorded the 4 main operations and their inverses. You should also have done this practice exercise here. And remember, for each one of those equations, you needed to write down the solution, x equals, and you need to have written down the inverse operation. And with the people around you, you need to have talked through how we could say that equation in words. Okay, and the answers are all here. You don't have to write all of those 10 down in your books, but here they are here. Right, so the goal is that we need to get really good at linking up words with equations, knowing what a solution is, and knowing how to keep an equation balanced. Then from this slide, I want you to have in your book the 3x minus 2 equals 22, and this bubble diagram, just one of them. And the working for one full example done algebraically. From the last slide, there were these 2 examples, and most of you will have been able to figure out those as you go, but they also need to be recorded. Okay, so I know it's not a very exciting lesson, but it's pretty fundamental for learning how to work with more complicated equations in real life settings. And that's what we're coming to in about 2 lessons time. So thanks for watching, and I'm going to make another video now with some harder examples, different types of two-step equations.